Decision tree analysis, or DTA, uses a tree-like structure to analyze potential outcomes and consequences in our decision space for risk management. In this video, we'll create and share a dynamic template in Excel with three easy steps: drawing decision trees in Excel for risk management, analyzing the decision space to find expected monetary value or EMV, and understanding contingency reserve and management reserve in project management certification exams. You can follow along by getting the Excel workbook via the provided link in the description below. Step 1 is drawing decision trees in Excel for risk management. A construction company plans a project with an estimated base cost of $200,000. The project faces two independent risks that could increase costs. Risk A has a 30% likelihood that unexpected soil conditions require additional foundation work. The post-mitigation or residual impact is an extra $50,000 to the cost. Risk B has a 20% chance that supply chain delays lead to an increased material cost. The residual impact is $30,000. The company needs to determine the optimum contingency reserve, or R, to add to the baseline cost. We aim to keep the probability of total project cost exceeding the baseline plus the reserve at less than 10%. In other words, we want to find an R value that prevents cost overrun by a confidence level of 90% at all times. This reflects a risk management policy to ensure sufficient funds with high confidence. First, we need to draw our tree to visualize the decision space. Navigate to the Insert menu and choose Smart Art. From the Hierarchy group, select Horizontal Organization Chart. Feel free to remove the unwanted elements. Label the decision node as Contingency Reserve and choose an appropriate color. The two main chance nodes are Risk A doesn't occur or Risk A occurs. You may color code nodes by shades of green and red. Continue by making two sub-branches by using the side dialog box. Created sub-branches can be indented by pressing Enter, then Tab button. The chance nodes are Risk B doesn't occur or Risk B occurs. Deciding on the amount of contingency reserve, we now have four combinations or scenarios. The base case can be colored green, where neither of the two risks happens. Average cases can be colored dark blue, where one of the two risks occurs. The worst case scenario can be colored in red, where both risks occur. This decision tree simplifies our complex decision making by visually mapping potential scenarios. This makes it easier to identify the optimum project contingency reserve. Step 2 is analyzing the decision space to find the expected monetary value, or EMV. We should structure our data in a tabular format for our quantitative decision tree analysis. The color coding of scenarios here can match our decision tree. We should now estimate the probabilities of each outcome and assign payoffs or costs to each branch, which reflects the impact of each decision. For example, the first probability is related to neither of the two risks happening. We can match the color coding here with the decision tree. Risk A has a 30% chance of occurring. Therefore, the probability of non-occurrence is 1 minus 30%. This should be multiplied by 1 minus 20%, which is the non-occurrence probability of risk B. The result is 56%, and there is zero additional cost in this branch of our tree since this is a risk-free branch. The expected monetary value, or EMV, will be the original project cost of $200,000. Next is an average scenario in which we must calculate the integrated probability of risk A's non-occurrence and risk B's occurrence. The probability is the product of 1 minus 30% and 20%. This means there is a 14% chance that an additional cost of $30,000 is incurred due to risk B occurrence. Project EMV is the sum of $200,000 and $30,000. Moving to the third scenario, we must calculate the integrated probability of risk A's occurrence and risk B's non-occurrence. The probability is product of 30% and 1 minus 20%. This means there is a 24% chance that an additional cost of $50,000 is incurred due to the risk A occurrence. Expected monetary value is $250,000 for this outcome. Our final branch, or the worst case scenario, is related to both risks A and B occurring. The integrated probability is the product of two likelihoods of 30% and 20%. In this branch of our decision tree, there is a 6% chance with a combined impact of $50,000 plus $30,000. The project EMV in this scenario equals the initial project cost plus the additional cost, which is $280,000. With our values in hand, we can calculate the cumulative probability of our project having a maximum cost of $200,000. This is equal to the first branch probability, or 56%. The cumulative probability of our project having a maximum cost of $230,000 is the sum of previous cumulative probability and likelihood of the second branch, which equals 70%. We can replicate the formula for other branches. The final results show that likelihood of the total project cost being $280,000 or less is 100%. In the final step of analyzing our decision space, we should specify the contingency reserve values for our four scenarios. The EMV of $200,000 for the first branch is identical to the planned project cost, suggesting that contingency reserve is 0. This is a risky decision since the chance of total project cost exceeding the base cost plus reserve is 1 minus 56%. The exceedance or cost overrun probability of 44% is beyond our tolerance level of 10%. The EMV of $230,000 for the second branch suggests that contingency reserve is $30,000. This is again a risky decision since the chance of total project cost exceeding the base cost plus reserve is 1 minus 70%. The exceedance probability or tail risk of 30% doesn't satisfy our desired confidence level. The EMV of $250,000 for the third branch suggests that the contingency reserve is $50,000. This is a viable decision since the chance of total project cost exceeding the base cost plus reserve is 1 minus 94%. The exceedance or cost overrun probability of 6% is less than our tolerance level of 10%. Finally, the EMV of $280,000 for the fourth branch suggests that the contingency reserve is $80,000. This decision is too conservative since the chance of the total project cost exceeding the base cost plus reserve is 0%. Based on our analysis of the decision space, the optimum value for contingency reserve is $50,000, which satisfies our problem statement in this project. May I pause the video here for a minute and quickly mention something? Our analytics show that only around 44% of the channel's regular viewers are subscribed. If you are enjoying our content, please don't forget to subscribe and turn on the notification bell. It's a free way to support us in continuing this learning journey. Thanks. Back to our template, and by animating decision tree analysis or DTA, we've created a powerful tool to compare expected monetary values or EMVs. This is an essential concept in PMI's exam for Project Management Professional or PMP, Certified Associate in Project Management or CAPM, and Prince 2. By animating this project management tool, we can systematically evaluate multiple decision paths under uncertainty, quantify risks and outcomes, and make data-driven choices that optimize expected project value. Step 3 is understanding contingency reserve and management reserve in project management certification exams. Project management certification exams are designed to validate your skills and knowledge in managing projects effectively. Contingency reserves and management reserves are crucial concepts commonly covered in project management certification exams. Contingency reserve refers to funds or time allocated to address identified risks, often referred to as known unknowns. These are specific uncertainties documented in the risk register, such as potential cost overruns due to supply chain delays or technical challenges. These reserves are calculated using quantitative techniques like expected monetary value or Monte Carlo simulations, ensuring there are enough resources to mitigate risk with a defined probability of occurrence. Project managers usually hold authority over contingency reserves, integrating them into project cost or schedule baseline to proactively manage anticipated issues. In contrast, management reserves are allocated for unforeseen events or unknown unknowns, which are risks not identified during planning, such as sudden regulatory changes or natural disasters. These reserves are not included in the project baseline but are held separately, often as a percentage of the total project budget or duration. Control over management reserves rests with senior management or the project sponsor and requires formal approval for their use. This process ensures that they are set aside for truly unexpected challenges that could jeopardize project success. Let's review some questions about contingency reserves similar to those asked in project management certification exams. Question 1. A project has 3 identified risks with the following probabilities and cost impacts. Risk A, 20% probability and $10,000 impact. Risk B, 30% probability and $5,000 impact. Risk C, 10% probability and $20,000 impact. Now, using the expected monetary value or EMV method, what's the total contingency reserve required? You may pause the video here to reflect on the solution. The scenario presents 3 risks with the specified probabilities and impacts. For instance, risk A has a 20% probability and $10,000 impact, resulting in an EMV of $2,000. For risk B, the EMV is 30% times $5,000, which equals $1,500. And for risk C, it is 10% times $20,000, which equals $2,000. The contingency reserve here equals the total EMVs. The total figure of $5,500 will be the contingency reserve, and option C is the correct response. Let's move on to question 2. What best describes the purpose of a contingency reserve? We have 4 options for this conceptual question, asking about the purpose of contingency reserves. We know that contingency reserves are allocated for known risks analyzed during planning. So the correct answer is option C, which is addressing identified risks that may occur. This is in line with PMBOK definitions. Now let's move to question 3. During which process is the contingency reserve typically determined and added to the cost baseline? We have 4 options for this question that test process knowledge based on PMBOK guidelines. We know that during the budget determination, reserves are added to establish the cost baseline. Therefore, option C is correct. Options like estimate costs or control costs are common distractors to test understanding of project processes. Now, question 4. A $20,000 contingency reserve exists, but an unforeseen regulatory change needs $15,000. Which reserve covers this? This question is scenario-based, distinguishing between contingency and management reserves. With an unforeseen regulatory change requiring $15,000, the answer is management reserve, as contingency reserves are for identified risks only. Management reserves address unforeseen events not included in the risk register. Now let's review some questions about management reserves, similar to those asked in project management certification exams. Question 5. Which of the following best describes the purpose of management reserve in project management? This question emphasizes conceptual understanding, specifically inquiring about the purpose of management reserve. The correct answer is to provide a buffer for unforeseen events not identified in the risk register, which aligns with PMBOK definitions. Options include distractors such as covering identified risks or funding scope changes. Let's move on to question 6. Who typically has the authority to approve the use of management reserve in a project? This question tests control and authority. Management reserve is known to be controlled by the senior management, not the project manager. Options such as a steering committee or functional manager are common distractors to assess understanding of governance. Let's move on to question 7. A project has activity cost estimates of $450,000 and a contingency reserve of $50,000. The organization sets a management reserve at 5% of the cost baseline. What will be the project budget? This question involves calculation. First, the cost baseline is $450,000 plus $50,000. Then, the management reserve is $25,000, which equals 5% of $500,000. Therefore, the total project budget is $525,000. Options are designed to capture calculation errors if they occur. And finally, question 8. Which statement is true regarding management reserve and contingency reserve? The question distinguishes management reserve from contingency reserve, with the correct answer being contingency reserve is controlled by the project manager, while management reserve is controlled by senior management. Other options, like both being in the cost baseline or misaligning risk types, test conceptual clarity. So, project management certification exams validate your skills and knowledge in effectively managing projects. Today, we've journeyed through decision tree analysis using the project contingency reserve as our case study. Decision trees provide a visual representation of various scenarios, which helps in allocating appropriate reserves to effectively mitigate risks. If you found this video useful, please consider subscribing. You can get the Excel workbook by the provided link in the description below. I'll see you in the next one.